All right, so for today in this section, we are talking about loans still. We're going to calculate the interest of a loan. Have we done that before? Yeah, we've already done that. So we're going to kind of review that part again. And then calculating the length of the loan. So that's that other formula on the bottom of that pink paper that you guys kept wondering about. But first, I want you guys to kind of see how a loan payment is used. So you buy a car, you buy a house, you buy whatever. Depending on whether it's a mortgage or a car, it doesn't really matter. It's all kind of used the same way. So this table shows you a loan that's $100,000, 7.5% interest for 15 years. And then the monthly payment, $927.01. Total interest paid for the life of the loan would have been $66,000, almost $67,000 in interest. Just keep that in mind. When we talk about mortgages for 30 years, and that's insane, the number of that interest. Take a look at the payments. So your very first payment, $927 payment, only $302 goes towards the principal. $625 of that goes towards interest. It's disturbing when you think about it. So then the next month, now it's up to $303.90, $623 towards interest. The next month's up to $305. That one's down to $621. But you see, as your loan balance gets lower and lower, more and more of your payment goes towards paying that off, and a little bit less each time goes towards interest. But that's how payments are done. I need you guys to see that. So if you're thinking about getting a loan for something, that's why I keep telling you to try to get the shortest loan length as possible. You're going to pay the least amount of interest that way. And anytime you can pay more per month, let's say your monthly payment's $927, but you can afford to pay $1,000. It's not a lot more, but it's a little bit more. That extra part over top of the $927 would all go directly towards your principal. So anything over the loan amount that you're paying, anything more per month goes directly on principal, not on interest. Okay, so any extra you can pay every month, definitely do that. So you mean if 1 month you pay more but the next month you can't? That's okay. As long as whatever the bank says your monthly payment is, as long as you pay at least that, you're good. But yeah, this month I got extra, throw it on there. Next month you don't, that's okay. Just make your regular minimum payment. Okay. You okay there? A little disturbing to look at? I know it is for me. When I look at that, I'm like, oh my gosh, I pay that much and only that little bit of it goes towards your loan. We're going to use both formulas today. All right, so number one, Hannah is taking out a 4.3% loan to purchase an $18,000 car. The length of the loan is 8 years. How much will she pay in interest? So, looking at that, in order to figure out how much she's going to pay in interest, what do you have to calculate first? Nobody knows? Say that again? Her monthly payment, right? If I can figure out how much she pays per month, I can figure out how much she pays over the life of the loan, then I can figure out how much, is interest, how much over the $18,000 she's paying. Can you use the table to get your payment? Why not? Good. Yeah, everything is all kind of wrong, right? Sorry, I'm adding on to my thing here. Okay. Go away. All right, so what do I have to do first? So on your pink thing, remember the middle says calculating monthly payments? You want to actually go to the monthly payment formula. So that's where we're going to start. So we are borrowing $18,000. And our rate, 0.043 over 12. 1 plus my rate over 12. 12 times. Looking at the quizzes, some people are putting weird numbers in here. For time, is time in months or years? It's in years. And I have a couple people in each class who are putting in months, so they're getting very wrong answers. So this is 8 years. Don't change that to months there. 1 plus 0.043 over 12. 12 times 8 minus 1. So everybody try it, because right now I have people on the quiz who had the formula written down right and had a wrong answer. So make sure everybody types it in. Yeah, they're on in PowerSchool. Thank you. Thank you. It looks satisfying. Dead or dying? Okay. For right now, grab a different one and just kind of set it to the side. I'll put new batteries in it later. All right, double check what you guys get. I got $221.93. Okay, that's what we should have. So what did I find? The monthly payment. So how do I find the interest? Very nice. I have to multiply this by 12 times 8. Why 12 times 8? Very good. Very nice. Elena's on it today. So that's my monthly payment. I'm going to make that 12 times a year, right? There's 12 months, and I'm going to do that for 8 years. Now, in your calculator, do not use all those digits. If you have it sitting there, don't just hit times 12 times 8. You have to actually type in the 221.93. Okay, don't leave all the digits in there. Times 12 times 8. It's going to give you a different answer. So, $21,305.28. What is that? This is how much I've paid, right? So that's the total amount paid in 8 years. Good. Then we'll subtract the $18,000 because that's how much I actually borrowed. So I paid $3,305.28 in interest. What's another word for interest? Finance charge. Okay. This process was on your quiz on Friday. Are we okay? The quizzes were either like, yay or nay. Now, my other class, my D block was really yay or nay. Like that class was like, I think they had like 14 A's and like 3 F's. There was not much in between. This class was a little more like, I think they had like 6 or 7 A's, like 5 B's, 5 C's, and a couple D's, a couple F's. I don't remember. I graded them on Friday. Not everybody's finished. Later. Not now. Not now. Number 2, determine the total interest owed on a 5-year, $10,000 loan at 6% APR. Can you use the table? I heard a yes, I heard a no. Yeah, it looks like you could, right? You got the 5-year, you're like 6% is a nice number, but the table starts at 6.5. So I can't actually use the table. So we will go back to the monthly payment formula. So guys, I'm going to do this by myself up here. I'm not going to say a word. You guys do it by yourself, and when you're done, look up. Okay? Sound good? guys, questions on number 2? Anybody not able to figure out how all that works? John, you good? All right. So guys, the next part we're going to talk about is that new formula that's on your paper. Now, I will tell you that if you've not already fixed it, for whatever reason, when that copied, you can't see the fraction bars inside of there. So if yours are not there, make sure you draw in the fraction bars. So yeah, all those fraction bars are missing. All right, guys, so this loan length formula, this is what you would use if you're like, I want to borrow this much money and I can afford to pay like 500 bucks a month, but I can't afford more than that. So then you could use this formula to figure out, well, how long of a loan would you have to have then? So that's what this is used for. This right here, these things right here, this is LN.
I thought it was about to be a logarithm.
It is. That's a natural logarithm. It is natural logarithm. All right, so guys, that is a natural logarithm. The fact that it's a natural logarithm, it doesn't really mean much to you guys. You have a button on your calculator that says LN. That's all you need to know. That is a natural logarithm, which is used in algebra. It's okay. We don't have to worry about that. All we know is the button is right there that says LN. Okay? Yeah. Yep. No, that's a lowercase l. When I write my formula, I always do cursive L's, like I do them like a loop to them, just so you know what they are. All right. So let's go ahead and work through this. Claude wants to borrow $25,000 to purchase a car. After looking at his monthly budget, he realizes that all he can afford to pay per month is $300. The bank is offering 5.9%. What would the length of the loan need to be so that he can stay within his budget? Now, before we even get into the formula, how do you know when to use this formula? It literally is asking for the length of the loan, okay? Don't go by just they give you the monthly, because they could be asking something else. So I need to make sure, this should be the easy one to figure out when to use, right? It will literally ask, how long of a loan should I have? Use the loan length formula, okay? So let's go ahead and plug our numbers in here. So T equals, because we're trying to figure out the time. So that is a natural log. So I always make mine cursive so you can tell kind of better what it is. The capital M stands for what? Monthly payment. And he can afford $300 a month. Divided by what's P? Principal, which is $25,000. Notice where those parentheses are, okay? Some of you have a tendency to put them in the wrong spot. Minus natural log, 300 over 25,000 again, minus my rate, 0.059 over 12. All of that is over top of 12 times the natural log of 1 plus my rate, 0.059. Over 12. Now, this formula looks like somebody is really smart and used all kinds of magic, right, to get this to work. All this formula comes from, and granted, I don't expect you to be able to do it mathematically, is they took the monthly payment formula and they solved it for T. That's what happens. Okay? So that's just them taking, somebody used algebra to solve this formula for T, and that's what it comes out as. Okay? All right. So again, calculator, let's practice. You need to start with your fraction again. So green button, y equals what? Hold that thought. Okay. All right. So start with your fraction. Green button, y equals. Then we're going to hit the natural log, so that ln button, which is 2 buttons above the on. Notice it put the little ln right in your formula, right? What else do you notice when you hit ln? What happened? It automatically opened a parenthesis for you. Okay, so I'm going to do 300 over 25,000, close parenthesis, minus natural log again, and again it automatically opens up that parenthesis. 300 over 25,000 minus 0.059 over 12, close parenthesis. And on the bottom, we're going to have 12 natural log, it opened that parenthesis again, 1 plus 0.059 over 12. Just hang on to it. I'll put batteries in it. Don't put it back if it's set. Just grab one for now. So you get 8.95, blah, 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 bunch of things. So how long of a loan do I need? I need 9 years. All right, so guys, on this, if Claude wants to borrow $25,000 and only pay $300 a month to pay that off, it's going to have a 9-year loan. Now, what do you think? They're buying a car. Are they going to give you a 9-year loan? No, they're not. They're not. So that's something you have to kind of take into consideration there. Now, question 3 asked, what impact would an increase in the monthly payment of $50 have on the length of the loan? So what am I changing? Good. The only thing I need to change here is the 300. Okay, board's got a mind of its own. The 300, change this to 350, and this 300, change to 350. So that's the only thing that needs change. So if you're calculator confident here, you can just go back up, bring up your equation again, and just change in the 2 spots that to 350. So you get about 7.4 years. So if it's about 7.4 years, how much did that lower the length I needed? By about a year and a half, roughly. For only an extra $50 a month, I can drop that by about a year and a half. So you would tell me then it decreases the length by roughly 1.5 years. Okay, so it changes. I mean, it's going to drop by almost a year and a half by an extra $50 a month. That's a huge, huge difference, you guys. Huge difference. All right, number 4. Jennifer wants to borrow $20,000. Her bank offers a 7.1% interest rate. She can afford $500 per month for loan payments. What should be the length of her loan to the nearest 10th of a year? So that one actually specified for you, to the nearest 10th. So let's just plug this in our formula and see what happens. Again, guys, practice, because you're using a new formula, different buttons. We want to make sure we know how all this works. You know. We use this formula actually for quite a bit. The formulas for this chapter get used a lot in other chapters. Guys, have you written the formula down? Have you typed it in? Do you have an answer? Good. Let's write and type without talking. Yeah, you got to start with the fraction. I have a length of about 3.8 years. I don't know. Logan? It says round to the nearest tenth. That's what that problem actually said. It said nearest tenth. Now, if it had just said how many years, I would have said 4. that's the nearest tenth, so 3.8 years. Is anyone not able to get 3.8? All right, number 5. What effect would a $50 decrease in Jennifer's monthly payment have on her loan, and what about a $50 increase? So, hold on, guys, focus. So a $50 decrease, that would change this number to what? 450, and change this one to 450. So again, hopefully you're getting more and more comfortable with your calculators. You can just go back and change that to 450. So that would give, so a 450 monthly payment would change it to 4.3 years. So that added, what, about a half year? Then the question also asked, what about a $50 increase? So if this was 550, arrow up so it's highlighted, and then hit enter, and then you can arrow back through it. Yeah, that saves you a lot of time than retyping everything. Yep, and I got 3.4 years. How are we doing, guys? Great. Questions on interest or the monthly, or figure out the loan length? Do you see where these could be useful formulas, though, as you guys are planning things in the future? You want to buy a car and whatever, you can kind of see, I can afford this much. Could I actually get a loan for that?